Welcome to MATLAB classes by Civil Thinking, and this is our another class on MATLAB tutorial. Now before I move on, I suggest you to please watch the video lectures in sequence as in the playlist so that you understand better. The playlist link of MATLAB tutorials is in the description, or also you can click on the pop-up on your screen. Now coming to the today's class, now in this class we are going to elaborate further the operation, okay, matrices operations, okay. Now in order to begin today's class, let us first introduce the what we learned from the last class. Now in the last class I have told you how to create a matrix, okay, column matrix and row matrix. So if you want to create a column matrix, so you will write A equal 1 semicolon 2 semicolon 3. For example, when you hit enter, it is going to create a column matrix, okay, of elements 1, 2 and 3. Why? Because this semicolon, the semicolon is used what for what to create a column matrix, okay. Now if you want to create a row matrix, you will use a comma or a space instead of a semicolon, okay. For example, if I create another matrix and store it in the B variable, you will write B equal open and close the square brackets, then you will write 1 space 2 space, for example 4. It is going to create a row matrix or row vector of elements 1, 2 and 4, okay. Now we will continue from this. Now how do we create a range of numbers? Because for example, if you want a matrix from 1 to 5, for example 1 2 3 4 5, okay. Now you can either write manually 1 2 3 4 5 or even 6 7 8 9, okay, and press enter, okay. But there should be some shortcut to create, because this is a range of numbers, right? So there should be some shortcut, okay. So we have a shortcut, so we will use a colon for this, okay. For example, if I write A is equal 1 colon 9, okay. Now it has created a a matrix from 1 to 9, okay. But if I write A is equal 1 is to 9, it is again doing the same thing, okay. So this is going to create a matrix in both way, okay. So but if I right now, the difference between each number is 1, right? The gap is 1. For example 1 2 3 4 5 6 7 8 9, the gap between two elements is 1. For example, between 2 and 1 it is 1, 3 and 2 it is 1. Now what if I want to create a gap, okay. So I will write, for example, A or I will write C equal open and close the square brackets, and in the square brackets I will write 1 colon 2 colon 9, okay. Now it is also going to create row matrix, okay, but the gap between the elements is going to be 2, okay. Now you can see 1 3 5 7 9, okay. Now between 3 and 1 the gap is 2, 5 and 3 the gap is 2 again, 7 and 5 and 9 and 7 also have gap of 2, okay. Now if you want to create a column matrix, but the same way, so what you have to do, you have to use the transpose, okay, this transpose sign, okay. So you will write, for example, D is equal open and close the square brackets 1 is to 3 is to 9, but this slash, okay, I mean apostrophe, okay, this is called an apostrophe, okay. So it is going to create a column matrix from the numbers 1 to 9, but that the difference between two successive numbers is 3, okay. So 1 4 and 7, okay. So let us move on to the other topic. Now let us talk about a few special matrices, okay. For example, we have like identity matrix, we have one matrix, or we have a random matrix, okay. We will talk about them one by one, okay. Now let us first talk about empty matrix, okay. Now if I write just these square brackets and hit enter, it is going to create an identity matrix, okay. I mean the empty matrix of 0 cross 0 order. Okay, now if I want to create an identity matrix, I will write I, and inside I will write the order and hit enter. Okay, so but if I write I and I will write 2 comma 4, it is going to give me an identity matrix of 2 rows and 4 columns. Okay, but if I just write one number, okay, only one number, it is going to give me a square matrix, okay, of order that number. Okay, here it is going to give me a square matrix of 6 cross 6. Okay, identity matrix. Okay, so what is an identity matrix? In which all the elements in the the diagonal are 1 and all rest are zeros. Okay, similarly we can create ones matrix in which all the numbers are 1, so I will simply write ones. Here I will write the order. For example, I want to create a square matrix, I will hit the enter. Okay, so it has given me a matrix. Okay, all the elements are 1 and it is a square matrix of 5 cross 5 order. Okay, now if I write ones 2 comma 4, it is going to give me what, all the 1 elements, but here the number of rows is 2 as you can see, and the number of columns are 1. Okay, now similarly I can create a matrix with all elements 0, so I will write zeros. Okay, in the bracket I will write 4, so it is going to give me a 4 cross 4 square matrix of 0 numbers. And if I write zeros 2 comma 4 or even 7, it is going to give me all elements are 0, but here the number of rows are 2 and the number of columns are 7. Right, now similarly I can we can create a random number by typing rand. Okay, it is going to give me a random number, any number between 0 and 1. Okay, but if I type rand in the bracket, I will write 4, it is going to give me a matrix of square matrix of 4 cross 4. Okay, rows and columns. Now if I write rand and in the bracket I write 3 comma 5, it is going to give me a random matrix of 3 rows and 5 columns. Okay, so these were just the basics. Now let us move on to some some basic matrix operations. Now if I talk about the multiplication of matrices, we have two types of multiplication of matrices, okay, or arrays. One is what? One is the matrix multiplication, then other is the scalar multiplication. Okay, now if we want to multiply two elements, two matrices, for example, this is our A matrix and this is our B matrix, right? Now if I write A asterisk B, now A asterisk B is what is the matrix multiplication. Okay, and we have a condition in matrix multiplication. For example, you are multiplying A and B, so number of columns in first, which is A, should be equal to number of columns in the second, which is B. Okay, now number of columns in A, as you can see here, it is 1 2 3 4 5 6 7 8 and 9, and to in order to multiply it with B, it should have the same rows. Okay, but right now in B we have only one row, the columns are 7, the row in the second is only 1, so it is going to throw me an error. Okay, I will show you how. As you can see, it has thrown us an error. Okay, now if we let me see B matrix and let me display this D matrix. Okay, now in the B, as you can see, the number of columns are 3, and in the D the number of rows are 3. Okay, so the B cross D will work according to the matrix multiplication rules. Okay, so B asterisk D, it did work. Okay, now if I write D asterisk B, it also work because the number of columns in D are equal to number of rows in B. Okay, now this was the matrix multiplication. Now what about the scalar multiplication? Okay, now what about the scalar multiplication? Now to carry out the scalar multiplication, we will use, for example, we will use dot and star. Okay, dot and asterisk. For example, this is our B matrix and this is our D matrix. Okay, so if I write A dot star not A dot, I will write B dot star D. It is going to give me the scalar multiplication. Okay, now let me give you to get a better understanding, let me first clear the screen. Now let us create a matrix of values 1 2 3, okay, semicolon 3 1 2 semicolon 1 1 4. Okay, now this is our A matrix. Let us create a same matrix, for example B. Okay, here I will change the elements a bit. So this is our B matrix. Okay, now I have three matrices. Now if I write A dot asterisk D, what it does, it multiplies the corresponding elements. Okay, for example here the first element is 1, in B the first element is 2, so it is going to multiply each element. So 2 times 1 is 2. Similarly here the 3 is the last element and here the 3 is the last element, so 3 times 3 is 9. Okay, so it multiplies the elements of same address. Okay, for example here what is the address of 1? The address of 1 is, it is in the second row and the second column, so it will get multiplied with second row, second column is this element. Okay, so this, remember, this is not a matrix multiplication, this is a scalar matrix multiplication in which each element gets multiplied to the same address of the other element, other matrix. Okay, so this was the scalar matrix. Now what about if I multiply 3 times A? Now you can see this is our A, right? A is this 1 2 3 3 1 2. Okay, now 3 times A is what? It is going to multiply 3 with all the elements. Okay, so it is going to be, here it is 1, it is going to be 3, here it was 2, okay, here it was 3, it is going to be 9. Okay, now what about if I write 3 dot star A? Now here also it is going to give me the same address. Why? Because when you multiply a number with a matrix, okay, in matrix multiplication the number gets multiplied to each, and also in the scalar multiplication it gets multiplied to all the elements. Okay, so whenever the scalar operation of a matrix and the matrix operation is the same thing, so if you use the scalar or the matrix operation, the result will be the same thing. Okay, now let us move on to the other topic. Now let's talk about power. Okay, now power, power, we use this symbol, right? We call this as caret, something like this. Okay, so we use this symbol to to add power. For example 2 to power 4, okay, 2 raised to power 3, for example. Now 2 raised to power 3 is what? 2 2 is 4, 4 2 is 8, it should give the answer of 8. Okay, now this is our matrix. Okay, first let me clear the screen. Now this is our A matrix. Okay, now if I write A caret 2, what it does, it raises the power of what? 2 to this. Okay, but what is A cross 2? Let me show you. A to the power 2 is what? It is A times A, right? So A to the power 2 is what? My apologies, it is not A star B, it is basically A to the power 2 means what? It means A asterisk A, right? So A to the power 2 is A times A, right? And this is a what? This is matrix multiplication, so here it should follow the matrix multiplication rules. Okay, so the number of columns in A should be equal to the number of rows in A. Okay, so number of columns is 3 and number of rows is 3, because they are same, and it didn't throw us any error. Okay, now for example, if I wrote another matrix B equaled 1 2 3 and second 2 1 and 2. Okay, now if I try to do this A caret 2, okay, not A caret 2, I mean B. First let me clear the screen. This is our B matrix. Now if I write B to the power of 2, it did show us error. What? It did show us error. Why? Because B to the power of 2 is what? Is B times B, right? So number of columns in B must be equal to number of rows in B, right? If this condition is fulfilled, then we can do this operation. Okay, now let us check the numbers. Now here it has 2 rows and 3 columns, so the number of rows are 2, the columns are 3, so they are not equal. So 8 to B to the power 2 is going to throw us some error. Okay, so let us move on to other topic. Now let us talk about sum of matrices. Okay, so here let us say, let me first clear the screen. Let us say we have this matrix, square matrix. Okay, 1 2 semicolon 2 1. Okay, and we have B matrix and it is some values. Okay, now they are both the square matrices. Now if I type A plus B, we are going to get the sum. Okay, so sum is basically the sum of these elements, right? Now this was about the sum of the two matrices, but what about the sum of specific elements? Okay, because A plus B has produced us the another matrix with the sum, okay, of corresponding elements. Now if I want sum of some specific elements of matrices, so how we do that? Okay, now let us say this is our A. Now if I write sum A, okay, it is going to give me the sum of the elements in each column. Okay, now for example, if we had, now this is our D matrix. Okay, now if I write sum of D, it is going to sum up all the elements. Okay, so 7 plus 4 is 11, 11 plus 1 is 12. Okay, now if we have another matrix, okay, for example 1 2 3 4, and if I write sum of A, then it is going to sum the all. Okay, now what if I don't want to sum all the elements? Okay, now what if I want to sum only these two elements only? Okay, so here we will write sum 1 to 3. Okay, 1 to 2. Why 1 to 2? Because this have the address of 1 and this have the address of 2. Okay, so if I write sum A, in the brackets I will write 1 is to 2, it gave me an answer of 3. Okay, now what if I want add 2 and 3? Okay, so the address of 2 is 2 and the address of 3 is 3. Okay, so from 2 to 3 I will write 2 colon 3. Okay, so I will write 2 colon 3 and it gave me the sum of 5. Okay, so this was about the sum. Okay, we know how to add the sum. Let us say now we have this matrix. For example, we have this matrix A. Okay, now we want to multiply it. Okay, multiply each element. Okay, now we will write PROD for product A and hit enter. It is going to multiply all the elements. Okay, now if we want to multiply the specific elements, okay, we will write A and inside here we will write the range. Okay, for example, we want to add from 1 to 3 only. Okay, so it is going to be add 1 to 3. Okay, 1 plus 2 is 3, 3 plus 3 is 6, so we got 6 as the answer. Okay, now This was about the sum and the product of the matrix. Okay, we also found how to multiply the specific elements. Okay, so let us move on to other topic. Now let us talk about cumulative sum. Okay, cumulative sum and cumulative product of elements of a matrix. Okay, now until now we talk about the the sum of the matrix. For example, this was our matrix and we just wrote up the sum and it summed up all the elements. Okay, now what we write cumulative sum. So cum is cumulative sum of A. Now it is going to return a matrix. Okay, but each element will be the cumulative sum. Okay, so let me give you comparison. So here the first element was 1, so first element will be as it is. Okay, now second element will be the second element plus the 1 before it. Okay, so 2 plus 1 is 3. Okay, now third element is going to be the third element plus all the numbers before it. So 3 plus 2 is 5, 5 plus 1 is 6, so we got 6. Okay, now fourth is cumulative sum of 4 is what? 4 plus sum of all others. Okay, before it. So 4 plus 3 is 7, 7 plus 2 is 9, 9 plus 1 is 10, so we got 10. Okay, similarly we know if we have this matrix and we want to multiply all the elements of A, we write product of A. Now what about the cumulative product? So we write cum for cumulative product, okay, of A and hit enter. So the same way it is going to multiply. Okay, so the first element will stay as it is. Okay, as it is. Then 2 is what? 2 multiplied by the number before it, so it is 1, so 2 times 1 is 2. 3, the cumulative product of 3 is 3 times the numbers before it, so 3 times 2 is 6, 6 times 1 is 6. Okay, so it is 6. Similarly the cumulative product of 4 is 4 multiplied by all the numbers before it. Okay, so 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24. Okay, so we got 24. Okay, so this was the cumulative product in MATLAB. Okay, and cumulative sum. So let us move on. Now let us talk about the exponential. Okay, exponential. Now we know exponential e to the power something. Okay, so we write exp. For example, exp of 2 is what? E to the power 2, right? So it is 7.389. Okay, now this is our matrix. So if we write exp of A in the brackets, so it is going to what? It is going to, for example, here we have 1, so it is the element is going to be e to the power 1. Okay, so it is 2.7183 because the value of e is 2.7183 approximately. Okay, similarly the 2, it is going to be replaced with exponential of 2, which is this. Okay, so exp A, what it does, it it applies the exponential to each element. Okay, but remember this is not a matrix exponential. Okay, so matrix exponential, what we do, we write exp m, okay, A, but here is a condition, it should be a square matrix, so this will throw us an error. Okay, so if I write a matrix, a square matrix 1, 2 and 3, 4, 3, 2. Now if we apply exponential here, it is going to work. But which exponential? Matrix exponential. Okay, so exp m of A, it did work. Okay, but remember this is different. I will show you if I just write exp. Let me first clear the screen. Now this is our A. Now if I write exp of A, it is this. Now if I write exp exponential m for matrix of A, it is going to be different. Okay, now you can see the difference because exp of A is the simple exponential of each element. Okay, but exp m is the matrix exponential and it is different from this. Okay, because in some topic, in some video lecture, we will be talking about exp m, okay, matrix exponential. Okay, because they are the different concepts, so you will get different answers. Okay, so let us move on to other topic. Now let us talk about concatenation. Okay, concatenation in matrices. Okay, now concatenation is what? When you place one elements of one matrix besides below or to the right or somewhere, that is known as concatenation. Okay, so how do we add? For example, you have this. Let me first clear the screen. So we have this A matrix. Okay, now let's define the B matrix. This is B. So if I write in the square brackets A semicolon B, what it is going to be do? Semicolon, after semicolon we get the another row. Okay, so it is going to throw the B below A. Okay, so semicolon means below. Okay, so A semicolon B means B is below A. Okay, so A is 1 2 3 2, so B is this, so 5 2 7 1 is going to be below it. Okay, so if I execute this, you can see. Okay, now we have placed B below A. Okay, now how about we place B to the right of A? Okay, so we will use what? We are going to use comma here. Okay, so we'll use A comma B here. Let me first clear the screen. Okay, so this is A, this is B, so I wrote A comma B. Okay, so A comma B is what? So this is A, okay, comma B. Okay, B is all of this. Okay, so the semicolon places the below, okay, and the comma places to the right. Okay, now let me clear this. Now this is our A, this is our B. Now what if I want to place B to the left of A? Can you think of what I am going to do? I want to place B to the left of A, so I will first write B, okay, then A. Okay, you can see 5 2 7 1, okay, is first, and then we have elements of A. Okay, now this is our A, this is our B. Okay, now we know the concatenation. Now how about I want to place A below B? Okay, so I am going to write B semicolon A. Okay, so A is going to be after below B. Okay, so B is this 5 2 7 1, so here it is 5 2 7 1, and 1 3 1 2 3 2 is A, which is below. Okay, so I hope you understand this. So let's move on to other topic. Now let us talk about the transpose. Okay, so let me clear the screen. So if this is our A, okay, so I want transpose. Transpose means interchanging rows to the columns and vice versa. Okay, so if I write A and I place this apostrophe, so it is going to give the transpose of A. Okay, so here you can see, here in A 1 2 was a row, but here the 1 2 is a column now. Okay, similarly 3 2 was a row and 3 2 is a column now. Okay, so interchanges rows and columns. Okay, so let us move on to other topic. Now let us talk about fetching of elements. Okay, so let me clear. So fetching of elements in a matrix. Okay, so this is our A. Now I want to fetch this 1. Okay, now what is the address of 1? It is 1 comma 1. Why? Because 1 is in the first row and in the first column. So if I write A in the brackets, I will write 1 comma 1. It is going to give me the fetch this element. Okay, now what if I want to fetch this element 2? Now what is the address of 2? What is address? Address is in which row it is and in which column it is. Okay, row comma column. Now this 2 is in the second row, so it is 2 comma, and it is in the second column, so 2 comma 2. So if I write A 2 comma 2, so it gives us 2. Okay, now what if we want to fetch multiple elements? Okay, so let me first clear. Now if I want to fetch multiple elements like these 2 elements, okay, so they are in the same row, right, row 2, but the 3 is in column 1 and 2 is in column 2. So I will write, because they are in the same row, So row will be the same, row is 2, right? But the column is what? From column is what? 1 to 2, right? So we are getting this 3 2. Okay, so I hope you understand. If you have any doubt, you can comment or you can contact me. Okay, so that's it for today. See you in the next class. Thank you.